Common expressions. When you go to calculus, you really have to know those three expressions. X to the power of 2 minus b to the power of 2 equals a plus b times x minus b. A plus b to the power of 2 equals a to the power of 2 plus 2ab plus b to the power of 2. And a minus b to the power of 2 equals a to the power of 2 minus 2ab plus b to the power of 2. Example: x plus 4 to the power of 2 is x to the power of 2 plus 2 times x times 4 plus 4 to the power of 2, and we get x to the power of 2 plus 8x plus 16. Example: x to the power of 2 minus 6x plus 9. You should know that this is x minus 3 to the power of 2. In calculus, we are going to use both ways. If we have some sum or difference in the power of 2, we need to know how to expand, but also we need to take a quadratic and write it as product of terms. In this case, it is x minus 3 times x minus 3, or in short, x minus 3 to the power of 2. We can check that by expanding. Example: x to the power of 2 minus 9 is definitely x plus 3 times x minus 3. But also x to the power of 2 minus 5 is x to the power of 2 minus square root of 5 to the power of 2, which means we can write this as x plus square root of 5 times x minus square root of 5. But even more, we really have to enlarge our horizon here before we take calculus. For example, if x is greater than 0, then we can do even more. If I have x minus 5, I can write this as a product of two terms, because if x is positive, then x also equals square root of x to the power of 2. And obviously 5 is square root of 5 to the power of 2. So this can also be written as a product of square root of x plus square root of 5 times the conjugate, which is square root of x minus square root of 5. Rules of exponents. Make sure you know them very well. X to the n times x to the m is x to the sum of the exponents. X to the n to the power of m is x to the power of the product of the exponents. 1 over x to the n can be also written as x to the power of negative n. An nth root of x can be also written as x to the power of 1 over n. X to the n over x to the m is x to the power of n minus m. And x to the power of m over n can be written in two ways. It can be written as the nth root of x to the m, or as the m power of the nth root of x. Let's learn about lines. Here is a line. Let's pick 2 points on the line. The slope of a line, which is denoted by m, is rise over run, or the difference of the y's over the difference of the x's, because the difference of the y's is the rise, and the difference of the x's, which is horizontal, is the run. In this case, it is y1 minus y2 over x1 minus x2. We note that the slope of the line is constant, which means no matter what 2 points on the line you will choose, if you will calculate the difference of the y's over the difference of the x's, you will get exactly the same. We are calling this b. This is the value of the y where the line is intersecting the y-axis. We call it also the y-intercept. The slope-intercept equation of a line is given by y equals mx plus b. The point-slope equation of a line is given by y minus y1 equals x minus x1 times m. Example: let's find the equation of the line that passes through the points 1, 2 and negative 2, 4. What is the y-intercept of the line? We are going to use first the point-slope equation. The slope is just the difference of the y's over the difference of the x's, and we get negative 2/3. We have to pick one of those 2 points to be the point. I'm going to pick the first one. And I get that. Now I would like to simplify because I would like to write it as y equals mx plus b because I need to find also the b. So this is just simple algebra. And I get this. Simplify more and we get that. So as you can see, we have here y equals the slope, which is negative 2/3 times x, plus a number. This number has to be b. So the y-intercept in this case is 8/3. Here is a very special line. The equation of this line, which is, you can see it's a vertical line, it's x equals a number. The equation of a vertical line is x equals a number. We are going now to say that the slope is infinite. This is a horizontal line. The equation is going now to be y equals a number, and the slope of this is a clear-cut 0. Example, find the equations of the vertical and the horizontal lines that passes through the point 1, 3. The equation of a vertical line is x equals a number. Because it passes through the point 1, 3, the x-coordinate equals to 1, which means that the equation of this line is x equals 1. For the second one, we are just doing the same. The equation of a horizontal line is y equals a number. Because it passes through the point 1, 3 with y-coordinate equals to 3, its equation is y equals 3. Here are 2 lines. The green line is y equals m1 plus b1, and the red one is y equals m2 plus b2. As you can see, those 2 are perpendicular or normal to each other. In this case, it is well known that m1, which means the slope of 1, is the negative of the reciprocal of the second one. So m1 equals negative 1 over m2. But this is also true that m2 equals negative 1 over m1 because, again, the slope m2 is the negative reciprocal of the first one. When we have 2 parallel lines, it's really easy. They have the same slopes, so m1 equals m2. Find the line that is perpendicular to the line y plus 2x plus 10 equals 0 and passes through the point 1, 3. The slope of the line is the negative reciprocal of the slope of the line that is given in the problem, y plus 2x plus 10 equals 0. So first we need to find the slope of this one. We are going just to write it differently as the slope intercept. Y equals negative 2x, negative 10, and we get that the slope is negative 2. It means that the slope of the line that we are looking for is the negative reciprocal of negative 2, which is 1 over 2. Now we have a point, and we have the slope, so we can use the point-slope equation. And we get that. We can just simplify. And even simplify more. And we get that y equals 1 over 2x plus 5 over 2. It is nice to simplify because you can see that the slope of this line is 1 over 2, which is exactly the negative reciprocal of the first line that is given in the problem, which is -2.